Hey guys, this is Mrs. Foy, and this is the screencast about stoichiometry. Stoich is a branch of chemistry where you are going to be able to predict the amount of how many reactants or products are made. Probably one of the most useful things in chemistry that we have. I would highly recommend, if you haven't checked it out, go to the PhET website. If you go to phet.colorado.edu, there's all these awesome simulations, and one of them is a simulation about stoichiometry, and it starts out with just a very simple problem where you're making a cheese sandwich. And the idea that the reactants are the ingredients, like the bread and the cheese, and then you can, depending on the ratio of bread to cheese, that tells you how many products that you can make. So here I can look at my balanced equation, which is the recipe, right? So 2 pieces of bread for every 1 piece of cheese gives me a sandwich. So if I had 7 pieces of bread and 3 pieces of cheese, I could make 3 sandwiches. I would actually have bread left over. And what is limiting me in the reaction is the amount of cheese. I'm going to run out of cheese after I make 3 sandwiches, and I'm going to have some bread left over. And so just like this simple simulation, I am going to use the balanced equation in my stoichiometry problems to predict how much product or how much reactant I'm going to need. And I need the balanced equation because these coefficients, the big numbers in the front, are going to give me the ratios that I need to make my products or reactants. So here I've got a ratio of 2 to 1, 2 breads for every 1 cheese. So this is a good way to kind of think about stoichiometry. So to do a stoich problem, you have to basically do 4 steps. You have to get a balanced chemical reaction. And the coefficients, the big numbers in the front, are going to be the mole ratios that we're going to use. The second step is you have to get everything into moles. So you cannot do a mole ratio until you have everything in the moles. And then the third step is the stoich step. You do a mole ratio. So in the case of what the problem that we just did, it would be 2 moles of bread for every 1 mole of cheese. That would be the mole ratio. And then you have to get your answer in the correct units. Normally your answer is not going to be in moles. The person who's giving the problem is going to ask you to convert that. So I have my students do something called a mole map. And what they do is they are looking at how you can convert back and forth from moles to all these different units. So you can go back and forth using Avogadro's number if you want to know number of particles to moles. You can go back and forth with mass if you know the molar mass. And with gases, the easiest one is you have the gas at STP. You can use 1 mole is equal to 22.4 liters. And if the gas is not at STP, then you have to know the temperature and the pressure. You always have R, and the volume, and then you can get number of moles. And you can go back and forth with molarity. So if you know the molarity, which I tell my students, always write molarity as moles per liter, and you have the volume, you can get to moles. So you're going to need to get to moles. Everything needs to be in moles for you to do the mole ratios, and that's the key to a stoich problem. So here we go. We're going to do 2 stoich problems, and here is my first stoich problem. If 250 milliliters of a 4 molar iron 3 oxide solution reacts with 25 grams of carbon to produce iron and carbon dioxide. Sorry, I should just be that happens. How many liters of carbon monoxide will be formed at STP? So I am going to use my nomenclature skills to write my reactants and my products. So this is iron 3 oxide plus carbon gives iron and carbon monoxide. Now I have to balance those. So I have to use my chemistry balancing skills, and these are going to be my coefficients. The numbers, the big numbers that I wrote in the front, those are going to be my mole ratios. And remember, if you have no coefficient in the front, you can just assume that that means a coefficient of 1. All right, so what I'm going to do with that balanced reaction is I'm going to take the information from the problem and I'm going to put them in these little boxes around that particular compound. So remember in the problem it said I had 250 milliliters of a 4 molar iron 3 oxide solution, and I had 25 grams of carbon. So this is set up exactly like that bread and cheese problem that we just did. Here's my bread and here's my cheese. And so I have to do 2 mole ratios. I have to do 2 mole ratios to see which one I'm going to run out of. So the one in green, the mole ratio in green, I'm going to do to see the ratio between the iron 3 oxide and the carbon monoxide. And then the blue ratio is going to be the mole ratio between carbon and carbon monoxide. So I've got my balanced equation. I have all my materials. I know what I want here. I want the number of liters at STP. So now I'm ready to go. So I'm going to find out my bread first. So I'm going to do the bread Stoich problem first. And so what I'm going to do here is I'm going to take what I'm given, 25 milliliters of iron 3 oxide. I convert that to liters. I know to start with a single unit because I want a single unit answer. So I get to liters, and then I can use my molarity, and I get to now moles of Fe2O3. And so now I got to moles. So now I can do the mole ratio. So guys, this step right here is the Stoich. It is 3 moles of carbon monoxide for every 1 mole of iron 3 oxide. And you might say, well, where did you get those numbers, Mrs. Foy? I got the 3 here and the 1 here. Those are the coefficients. So now my moles of Fe2O3 cancel, and now I'm in moles of carbon monoxide. And so because my question asks liters at STP, I need to convert from moles of carbon monoxide to liters. And so 22.4 liters is the volume of a mole of any gas at STP, and so that's going to give me 67 liters of carbon monoxide if I use up every scrap of my Fe2O3. Now I'm going to do the blue problem. The blue problem is the cheese. Now I'm going to see if I used up every drop of my carbon, how much carbon monoxide am I going to make? So here I am going to be looking at 25 grams of carbon. I need to get to moles. So I'm going to use my grams, my molar mass of carbon, and now I'm at moles of carbon. Once I get to moles of carbon, I can use my mole ratios. This is the Stoich step. So I look at my balanced equation and I see, okay, for every 3 moles of carbon monoxide, there are 3 moles of carbon needed. And so that's where I get this 3 to 3 right here. And then because the question said liters of carbon monoxide at STP, I'm going to convert from moles to liters, and I get 47 liters of carbon monoxide. This is telling me how much carbon monoxide I can make if I use up all my carbon. This is telling me how much carbon monoxide I'm going to make if I use up all of my Fe2O3. Obviously, I'm only going to be making 47 liters of carbon monoxide because I am going to run out of carbon. Carbon is my limiting reactant. Okay, let's try another problem. Here we go. Our second problem. Hydrochloric acid and calcium hydroxide react to form calcium chloride and water. Here is my balanced equation. There's a lot of chemistry that goes into that. Your nomenclature skills and writing a balanced equation. So here I go with my balanced equation. So here's my problem. How many milliliters of a 6 molar hydrochloric acid solution will react with 150 milliliters of a 2 molar calcium hydroxide solution? So guys, I draw these boxes and I put all the information from the story problem into those boxes. And I can see that this is not going to be a bread and cheese problem. I'm not doing a limiting reactant because this particular problem is asking me the ratios between the 2 reactants. You can do that in a Stoich problem. It's not always about the products. So I have my balanced equation. I need to get to moles. Then I can use this mole ratio of 2 to 1 here, and then I can find milliliters. So here we go. Here we go. First thing we're going to do is we are going to get to moles, and I'm going to start with the calcium hydroxide. So in order to get to moles from the calcium hydroxide, I am going to convert milliliters to liters, and now I can use my molarity. So I'm going to use my 2 moles per liter. That is my molarity of my calcium hydroxide. And now the liters cancel and I'm in moles of calcium hydroxide. Here comes my actual Stoich step. This is the mole ratio. 2 moles of hydrogen chloride for every 1 mole of calcium hydroxide. Where did I get the 2 and the 1? From the balanced equation. All right? So now my moles of calcium hydroxide cancel, and now I'm in moles of hydrochloric acid. Now I need to get to milliliters. If I look back at my box here, I can say, well, if I'm in moles of hydrogen chloride or hydrochloric acid here, now I can use the molarity that was given to me in the problem, and I can cancel my moles. I just flip that molarity. I'm allowed to do that. 6 moles on the top, on the bottom, 1 liter on the top. So my moles, hydrochloric acid cancel. Now I'm in liters. I'm close to the end of my problem because I need milliliters, and so I just convert liters to milliliters. And so my answer, it looks like I've got 2 sig figs. And so my answer is 100 milliliters, or to be precise, 1.0 times 10 to the 2 milliliters of hydrochloric acid. So stoichiometry can be challenging. Hope that was helpful. I'll see you in class.